Hello and welcome to another video by www.electricalpereview.com. In this episode, we're going to be discussing the difference of reciprocal sums and product over sum of products and how to do them both by hand and with the calculator when you need them, and just some quick tips and tricks to make sure you get the math right. So let's jump on into it. Reciprocal sums pretty much look something like this. Z equals 1 over Z, which equals 1 over Z1 plus 1 over Z2 plus 1 over Z3. Now, when are we going to need this? This is, of course, anytime we have resistors in parallel like this. Here's our Z1, here's our Z2, and here's our Z3, and fault analysis like this. Here would be our utility contribution, followed by our transformer contribution or our transformer let through. Now, a lot of times you're going to see me do something like this. I'm going to say, instead of Z equals over here, the reciprocal of their reciprocal sums, I'm going to write something like this. Z equals Z1 in parallel with Z2 in parallel with Z3. Now, this is just kind of some notation I picked up from a math professor a while ago, and it kind of stuck with me, so I kept it up for myself. It's just kind of an easier way to represent this. I don't really think this actually means anything other than it's just a reminder that Z1 and Z2 and Z3 are all in parallel, and that's just two parallel lines. So I use this to show products over sum of products. I prefer product over sum of products versus reciprocal of reciprocal sums. They're the exact, you're going to get the exact same answer from both. So it all boils down to what you're most comfortable doing, what's most natural to you, what can you do over and over and over under pressure without making any mistakes. Here's what products over sum of products looks like. On the top, you've got every term multiplying together as a product. And on the bottom, you've got the sum of the individual products of all three. So here's Z1, Z2 plus Z2, Z3 plus Z1, Z3. Now, say if we only had two resistors, Z1 and Z2, it's a lot easier and quicker to do, and it looks something like this. Z would equal Z1 in parallel with Z2. And then since we only have two terms, it would simply be Z1 times Z2 over Z1 plus Z2. Now, we can do the proof later. I don't want to waste too much time doing it, but we could show that this right here is the same thing as 1 over Z1 plus 1 over Z2. When you multiply these out, you end up in this format. So really, reciprocal of sums and products over sum of products, it's going to get you the same answer. It's just two different ways to do it. So let's do some quick examples. Okay, so say we've got three different resistors in parallel. The first is 10 kilo ohms, the second is 20 kilo ohms, and the third is 30 kilo ohms. We want to find out what is the equivalent impedance. So if we were to combine all three resistors in parallel to form one equivalent circuit, what would the combined impedance be? So first, let's do it with the reciprocal of reciprocal sums method. We can say that over here, Z equals 1 over 10 kilo ohms plus 1 over 20 kilo ohms and 1 over 30 kilo ohms. When we punch this into our calculator, we come up with 5.45 kilo ohms. Now, there's a couple of different ways to do this in your calculator, and again, it all boils down to preference. You can use the 1 over notation and add them like that, and then do 1 over your final answer. Or I think the easiest way to do it, if you have the inverse or reciprocal button on your calculator, which is just an exponent of -1, a really easy way to do this up here with your calculator is just to say you could do 10 kilo ohms minus 1 plus 20 kilo ohms minus 1 plus 30 kilo ohms minus 1, and then you could hit enter, and then whatever answer it gives you, and I'll do it real quick here. So we've got 10,000 inverse 1 plus 20,000, inverse 1 plus 30,000, inverse 1. That would give us, it looks like something like 0.000183. That's the answer for the sum of these reciprocals. If you go ahead after you hit enter, if you just hit the -1 button one more time on your calculator, it'll do the final reciprocal for you, and you'll get the answer of 5.45 kiloohms. I find that this is the easiest way to do it when you're working on your calculator. It's just a lot more simpler than hitting the 1 over button plus the 1 over button plus the 1 over button and then doing it one more time. It's just going to save you some mistakes. So try that if you like it. Use it, stick with it. If you don't, use whatever you are comfortable with. So I want to do the same thing, but I want to do products over sum of products just to show you that we're going to get the same answer. So over here, I can say this is the same as Z equals 10 kiloohms times 20 kiloohms times 30 kiloohms. That's the products. And then we're going to take the sum of products. So we're going to have 10 kiloohms times 20 kiloohms plus 20 kiloohms times 30 kiloohms plus 10 kiloohms, oops, running out of space here, times 30 kiloohms. So we're going to do this real quick on our calculator, and we get the same answer of Z equals 5.45 kiloohms. Now you'll notice this seemed to take a lot longer than doing it this way. I recommend when you have more than 2 terms to do the reciprocal method using just this really easy way I showed you on the calculator, just by using the inverse button for each of your terms, adding them together, pressing enter, and then using the inverse button one more time on that answer, right? However, I recommend using this method when you only have 2 terms. So if you've got 2 resistors in series, or if you're doing a fault current analysis and you've got 2 contributing sources, it's much quicker in my opinion. For example, say we've just got Z1 and Z2. All you got to do is multiply them together, hit your enter button, and then whatever answer you get on your calculator, you hit the divide button and you add them together. And this would give us an answer of, it looks like 6.67 kiloohms. And we're going to do it the other way just to prove it's the same answer. We can say the inverse of 10 kiloohms plus the inverse of 20 kiloohms is going to give us 0.00015, and then we take the inverse of that one more time just by hitting the inverse button on our calculator. Well, that answer is still on display, and we come up with the same answer of 6.67 kiloohms. Okay, now one more thing I want to touch base on while we're on the subject, something that's really handy to know if you haven't already figured this out. Anytime you've got 2 resistors in parallel, if they're the same value, you can skip doing the reciprocal of reciprocal sums, and you can skip product over sum of products. You can simply divide the resistor by 2. Let me show you what I mean. Say this is a 25 kiloohm resistor, and this is a 25 kiloohm resistor. Anytime you've got just 2 in parallel and they're the same value, you can take that resistor and half it. So this equivalent resistance would be 12.5 kiloohms. And of course, to prove that it works, we're going to do it products over sum real quick. We're going to say 25 kiloohms times 25 kiloohms divided by the sum of the 2, which is 50 kiloohms, equals 12.5 kiloohms. And if we do it reciprocal of reciprocal sums, we can say, well, 25 kiloohms the inverse plus 25 kiloohms inverse, hit enter, and then hit the inverse button one more time on that answer. We get the same of 12.5 kiloohms. So just a quick tip, save you some trouble. Anytime you have 2 resistors of an equal value in parallel, your equivalent Z down here is always going to be that resistance value divided by 2. Okay, that's it for this video. Hope you enjoyed learning about reciprocal of reciprocal sums and products over sum of products. And of course, for more, come see us at www.electricalpereview.com, the ultimate online resource for helping you take and pass the electrical power PE exam. See you soon.